Section 2.6, proving angles congruent. We're going to prove and apply theorems about angles. A theorem is a conjecture or statement that you prove to be true. Postulates, definitions, those things are actually things that we don't prove. We use those for reasons, though. A theorem you can't use as a reason until you have proved it. Okay, so once it's proved, you don't have to prove it again, unless it's like a quiz or test or something. But usually I do the proofs that you use the theorems in instead of actually proving the theorem itself. Okay, so it needs to be proved before you can use it. The theorem part of it you probably defined in your definitions already. So for this vertical angle theorem, here's what I'd like you to write. Since it has a name, definitely use the name. And then vertical angles are congruent. Put a star by this one or highlight it because you use it a lot. Once you use it a few times, you definitely will just go, oh, that's a vertical angle theorem. And you won't have to know the number or anything. So I don't memorize the numbers. I use the ones that I know the names for. So vertical angles are congruent, no examples, no pictures. Now, what are vertical angles? Those are the angles that are opposite each other. I think we knew that already from the definitions that we've learned. So in this picture, angles 2 and 4 are the same. Do they not look the same size? They should, because those are both obtuse angles. And when you look at angles 1 and 3 in the picture, those are acute angles, and those are the same as well. So we knew what vertical angles were. Now we know they're the same. Okay, and that's going to help us in these proofs that we're going to prove in a minute. The proof of theorem 2.1, vertical angle theorem, if you restate the theorem as a conditional, it says this: if the angles are vertical, then the angles are congruent. So it kind of makes sense that we say that they are congruent. Here's your first proof of the day. I think you should copy the proofs down just as samples, because if you do have a quiz and there's one kind of like it, you can go, oh, I think we did one kind of like that. They're never completely the same, but the things that you do in them are the same over and over and over. So this is the proof of the vertical angles theorem. I'll make it just a little bit bigger. And again, you may not have to do this one, but things that we do in it are things that you're going to need to do in other theorems and proofs as well. So we are given that angles 1 and angle 3 are vertical angles. Okay, so we're going to write that in the given, but I'll give you a minute to, for this one, I would copy the given, the prove, and the picture, and then you can kind of just go with me as we go. Okay, so in the given, angles 1 and angle 3 are vertical angles. You're going to write it exactly how you see it. So angle 1 and angle 3 are vertical angles. And then if the given part wasn't there, the first reason, if you're taking what you're taking from the given, the reason is given. We can also go down to the very last reason and fill that in. The proof statements that angle 1 and angle 3 are congruent. So I'm going to put that at the very end. Oops, I lost my color. I don't know why. So last reason, angle 1 congruent to angle 3. And that's even if you had no other ideas what to do. Always do the first step, always do the last step. The only thing we wouldn't know at this point, if it was blank, would be the reason for number 6. So we'll go back up here. Now, the good thing about this one is that it kind of gives you some hints here and there. So I'm going to draw the picture on the board so we can kind of continuously look at it, and then we'll fill in the missing parts. Okay, so even if we didn't have any idea how to do this one, what we're going to do is we're going to look at reason number 2 and we're going to say, what does that have to do with anything? This one says angles that form a linear pair are supplementary. So this one is one of those unique ones that you kind of just have to learn how it goes. You would think that right here we do the definition of supplementary, but we don't. We have to say that they're supplementary first. So we're going to say angles 1 and 2 are supplementary. We know that because they're next to each other. And angles 2 and 3 are also supplementary. Usually if it's 2 steps that go with the same one, I'll leave 2 blanks for it. So in this one, we're going to say angles 1 and 2 are supplementary angles. And we can also say angles 2 and 3 are supplementary. This one is just one that is different. You just kind of have to get used to how they do it. Sometimes I'll even go like this on the outside so you know kind of they go together. There's 2 things you have to write, they just go together. So now that we know they're supplementary, what does that mean? What does supplementary mean? Yep, they add up to 180. So now that we know they're pairs, let's add them together and set them equal to 180. So I'm going to start with the top one on number 2. Measure of angle 1 plus measure of angle 2 equals 180. And we can do that same thing for the second one that we wrote. Measure of angle 2 plus measure of angle 3 equals 180. So supplementary angles equal 180. This is also the definition of supplementary. So if you want to put that in there, that would work as well. Remember, anytime you have a vocab word in the previous one, you use definition of that vocab word. So I would take either one. They basically are the same. And if it's in the same question or in the same thing, the reason is the same. You don't have to write it twice. So this is all for step number 3. It would be definition of supplementary in both places. So now that we know that these 2 equal 180 and those 2 equal 180, we can kind of do transitive here. I don't feel like it's set up like transitive. I feel like it's more of a substitution kind of thing. The book will generally use transitive when you're using 2 steps together, kind of. So I'm going to put substitution behind this, and I'm going to kind of show you why here in a second. Okay, if 1 and 2 add up to 180, and 2 and 3 add up to 180, wouldn't they be equal to each other? Since they both equal 180? They're doing it like that. So if 1 and 2 equals 180, and 2 and 3 equals 180, you can basically say that they're equal to each other. Okay, so this one's going to be measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. So basically they're putting those left sides together. I feel like it doesn't follow transitive perfectly, so students don't necessarily recognize it. So when I say it, I'm like going 1 and 2 add up to 180, 2 and 3 add up to 180, they both equal 180, so they must equal each other. It's more of a substitution thing where I would plug the 2 and 3 into that first 180 because I know it equals 180. So I kind of look at it a little differently. Sometimes transitive and substitution can be kind of interchanged. Now is when we kind of want to look to see what we can do with step number 4. I'm looking at 1 and 2 on the left, 2 and 3 on the right. Isn't there a 2 on both sides, measure of angle 2? So could we subtract that out of there? Yes. So look to see what you need. We need 1 and 3 left over. Well, this is how we do it. So we're going to say measure of angle 1 equals measure of angle 3. Because the angle 2's have been subtracted out. Now, I'm going to change that last reason to a little bit shorter reason as well. The book kind of likes to write out the definitions. I like to just say definition of congruent. So on this one, I'm going to say this is definition congruent because it's so much shorter to write. Now, for this one, anytime that you are looking at measures of angles and you need them congruent, you drop the m's and add a congruent symbol. That's how you use the definition of congruent. If you have the congruent symbol and you need measures, you drop the congruent symbol, put an equals in there, and then you have to put the m's in there. So it's reversible. You can do it either way. And this is one of those things that you can recognize even if you don't know anything else about the proof at all. You can recognize that this is in there. And I'll show you different things to look for when we're doing these proofs as we go. So for this one, it's not necessarily true that you need to know the exact proof. It's how do these things get written down? What does it look like? So you can use that same thing in another one that might use that same reason. So important things. This one is kind of important. You just don't use it very much. How is that written? If you need to say that it's, if you're given something that's a linear pair. This one you use a lot. And you could do the same like if they said complementary. The only difference would be they would be 90. I think my battery is going to go here any minute. This one. Oh, I lost my color again. Okay, so this last reason is important as well. Three common things that you see a lot. Now, here are problems that you might enjoy a little more because it's not proof style. Use the vertical angle theorem. So in this one, when you are looking at it and you're looking at the picture, look for the x. Those are vertical angles. You know that now vertical angles are the same. So what we're going to do is we're going to set those two things they're giving us equal, and we're going to solve for the variable. So on this one, these are vertical angles. They are the same. So 2x plus 21 equals 4x. They don't add up to anything. They're the same. So now you're going to get the x's on the same side. So I'll subtract 2x. So 21 equals 2x. Divide by 2. X equals 10.5. Now, if you plug the 10.5 in there, those angles that you get should be the same. So if you plug them in and you don't get the same thing, you must have done something wrong in the solving part. Most students do very well on this part of it. It's the proof stuff that gets a little trickier. So are these vertical angles? Are they across from each other and they form an x? Yep, if they are, set them equal. 3x equals 2x plus 40. Subtract 2x from both sides. X equals 40. Sometimes they'll have you plug them back in. If they do, they'll probably have angle names in there. This time it just says what's the value of x, so we can stop right there. If you plug them in, you get 3 times 40 is 120. And 2 times 40 would be 80. 80 plus 40 would also be 120. So you can kind of throw them in there and check it out to see that you got it. This is the proof using the vertical angles theorem. So let's do this one as well. I would probably copy this one down as well. Okay, so the very first step is to write the given in. Angle 1 congruent to angle 4. Next step, what's the next step that we do? Always? Go to the end, put the proof statement in there. So angle 2 congruent to angle 3 goes in the very last one. Jazzy, you're not reading, are you? Put the book away. These are difficult, so you got to watch. The more you watch, the more you learn. So even if you didn't know a single thing about this proof, you would already have 2. And you don't even have to know anything about it. Okay, the reason for number 5 is not proof. We have to figure that out. But sometimes you can figure things out by just looking at them. So when you look at the picture, Usually you go from step 1 to step 2. What did they do? But on this one, 1 congruent to 4 and 4 congruent to 2, there's not really any connection. So look at the picture. What do you see in the picture? 4 and 2, what kind of angles are they? Vertical angles. We don't really know because there's no box in there, but they're vertical angles. So we can say vertical angle theorem, or vertical angles are congruent, either one. So now we know that this one and this one are the same because that was given. And we also just showed that this one and this one are the same. So we can kind of use that, as we go. They're going to do a little transitive property here. If 1 and 4 are the same and 2 and 4 are the same, wouldn't 1 and 2 be the same? Because they kind of have the same color on there. So when you look at what they're given, 1 and 4 are the same, 4 and 2 are the same. When those middle parts kind of overlap, the first and last part has to be the same. So that's the actual transitive property that actually looks like it. So I'm going to say angle 1 is congruent to angle 2. Now, if you've used 1 already and you've used 2 already, you're probably done with those. You don't usually use them more than once. So now we're just going to kind of focus on the end. I'm looking at step 3 to step 4. I have 1 and 2 the same, and it says 1 and 3 are the same. But I don't know why 1 and 3 are the same, but if I look at the picture, what kind of angles are those? Those are vertical again. So if you get lost in the proof, go back to the picture and go, maybe that's something that I already know. 1 and 3 are also vertical, so I'm going to say vertical angle theorem again. Doesn't matter that I already used it, it's okay. Now I'm going to look at 1 and 2 and 1 and 3. This is going to be one of those that kind of uses transitive. The book will say transitive, but I don't think it looks like it because those middle parts aren't the same. So when they say 1 and 2 are the same and 1 and 3 are the same, I'm thinking that it's more of a substitution thing, but the book will probably say transitive again on this one. So I'm going to put both, but you pick which one you like better. Since there's ones in both of them, I would use substitution. So I'm going to write that one first. So substitution property. I'm also going to put transitive because the book may have put that. And I'm going to put congruence on that one. If there's congruent symbols in there, you put congruent. If there's equal symbols in there, you put equals. And then we can say 2 and 3 are the same. Sometimes you don't have to get rid of and go back to the measures. Sometimes you can just use the congruent symbols. Now, paragraph proofs are written in a different style. So with this one, maybe they are going to write this in a paragraph after they get this. So the book kind of goes right into paragraph proofs. We haven't had enough knowledge about even 2-column proofs to go right to a paragraph proof. What I do, even myself, if I have to do one, is I write it down in a 2-column format, and then I take it and I turn it into a paragraph. My paragraph might sound a little different than your paragraph, and that's why I don't really like them, because you can make them so different and look different that it's hard to correct. It's correctable, but it's harder to do. So for instance, on this one, I would say we are given that angle 1 is congruent to angle 4. By the vertical angle theorem, angle 4 is congruent to angle 2. If you use these two things, angle 1 is congruent to angle 4 and angle 4 is congruent to angle 2, you can use the transitive properties to show that angle 1 is congruent to angle 2. You can have them as wordy as you want to, but at least if you're looking at it, you can turn it into something. What I don't like in paragraph proofs, and this is kind of why I don't do them, is because most people have really short sentences and they start it out with the reason and they say the statement, or start with a statement and go to the reason every single time, and it doesn't flow very well. So I think it's just the lack of knowledge in how to say stuff. So, and we don't really have that. And then I'd say using the vertical angle theorem and angle 1 congruent to angle 2 and angle 1 congruent to angle 3, we can show that 2 and 3 are congruent using substitution. And you can say it a lot of different ways and still come out with that same thing. we need more background to do paragraph proofs, in my opinion. Here's another example. You don't have to write this down. We'll just read through it really quick. In this one, we're given that 1 and 4 are the same. Always mark them if they're not marked. So those are the same. This is the one that they did, and I already told you the one that I did. Angle 1 is congruent to angle 4 is given. Angle 4 is congruent to angle 2 because vertical angles are congruent. By the transitive property of congruence, angle 1 is congruent to angle 2. Angle 1 is congruent to angle 3 because vertical angles are congruent. By the transitive property of congruence, angle 2 is congruent to angle 3. Totally different style than what I said, both equally fine. That's why paragraph proofs are hard, because no two people write them exactly the same. Here's a few theorems at the end. You guys can go back and do these. Copy the name. This one is used kind of, I don't even want to say kind of a lot. It's just sometimes. And then you can do the words only. The next one, and I'll read that one really quick. I think there was a couple more. If two angles are supplements of the same angle, then the two angles are congruent. So if they have two small angles and they're both supplementary to the same angle, they must be the same. It kind of makes sense. I think this is the last proof. 1 and 3 are supplementary, 2 and 3 are supplementary. We have to show that 1 and 2 are the same. So again, the first step, angle 1, let me see if I have enough space. Let me stop this first. So given angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. Okay, so that's the given. Usually if I'm going to do this, I would number them. And if there's a number and then a space, it would mean you need another one for that particular reason. Okay, so 1 and 3 are supplementary, these two. And 2 and 3 are also supplementary. Okay. We can't say these are the same by the congruent supplements theorem because they're trying to prove it. And that's why these are harder, because you can't use the proof that you're actually trying to prove in it. You can only use the ones that you've learned so far. So if they're supplementary, how many degrees they add up to? 180. So I'm going to say measure of angle 1 plus measure of angle 3. 1 plus measure of angle 3 equals 180. And could we not do the same thing with 2 and 3? We can. Measure of angle 2 plus measure of angle 3 equals 180. If there's a vocab word in the given, definition of that vocab word. Okay, now that we have two things, does this kind of look like the last one that we did? We had two things that both equaled 180, so we can set them equal to each other. So measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. And that I would call substitution. The book would probably call that transitive. This should look familiar as well. Are there 3's on both sides? If there are, we can subtract them out. So measure of angle 1 equals measure of angle 2, subtraction property of equality. And if we look to see what we had, we should have had this written in already. Angle 1 is congruent to angle 2. That's the proof statement. And that one is, how do you get rid of the m's and turn an equals into a congruent? Definition of congruent. This one is one that after we do it a couple times, this will be one of those that you do recognize and you can get. So I'm going to say definition of congruent angles. Or definition of congruent would be okay. Here's another theorem. I blocked out everything that you couldn't write so you can do this whole thing. Congruent complements, it's pretty much the same as congruent supplements. If two angles are complementary to the same angle, they must be congruent. And theorem 2.4, all right angles are congruent. That would make sense. Theorem 2.5, if two angles are congruent and supplementary, then each is a right angle. That one isn't used very much in proofs, but it is used a little bit more in problems that you do. And I think that's it. So kind of a big lesson on how do you do proofs. They are hard. Don't get discouraged. Keep trying to put something new in every single day.